So I was just going to give a bit of a background as to who I am. As you can probably tell, I'm English, so I'll also be correcting Austin's pronunciation of the word routing and my surname. So I'm Patrick Stevens. I'm the tech lead of infrastructure at Calypso. So Calypso provide, so we're the open source maintainers for Fluent stuff. So all the ecosystem, Fluent Bit, Fluent B, Fluent Operator, and we're sort of the maintainers for it. But we also build some enterprise products on top of that as well. So I've been working, it seems a terribly long time, 21 years in software engineering professionally. I did start in defense, so I spent a very large time in defense, but more recently, probably the last 6-7 years, well, I was still in defense, but doing Kubernetes and containers before I moved over to a database company called Couchbase back in early 2021, which is where I first started using Fluent Bit. We were looking at observability there and how to add logging, output, and some of the metrics as well. So I put together a sidecar for Fluent Bit for the Couchbase operator. And as part of that work, I started contributing to the project, getting quite active on Slack, wrote quite a few blog posts and sort of tried to help out people that, I'd spent a bit of time figuring out the solutions to it and some of the workarounds and trying to help people and point them in the right directions. And then Calypso reached out and made me an offer in late 2021 where I moved over to them, became an open source maintainer as well around the same time. Although primarily I'm working on open source, it's CI/CD, the automation, some of the release management as well. But I've also been putting together some of our commercial offerings and dealing with the internal infrastructure, running our SaaS solutions and making commercial offerings to customers as well. So from my perspective on the open source side, I'm not a developer of Fluent Bit. I don't really understand the code in enough detail. Well, yeah, I can understand the high level aspects, but it's more about how do you use Fluent Bit? How does it work? What would I do with it rather than this is how, the internals of it work. So I'm going to focus on some of that today and give you hopefully fairly simple, it's a bit tricky, but straightforward examples for routing and some of those other aspects that you can use in Fluent Bit. You may have seen me if you're on the Slack. I probably spend far too much time on there. But yeah, I'm quite active on the open source Slack, so come join, say hi. Hopefully some of the people here have joined from Slack and I may have chatted to you or offered you a solution or hopefully solved some problems for you as well. So what we're going to do today. So I'm going to give just a quick intro to Fluent Bit, what it is. It's not going to spend too long on that, but the main focus is routing. So how do you get data from A to B? How do you take stuff from various inputs, send it to various outputs? How do you make data pipelines? I'm going to try and show you this with some straightforward examples. It's a bit tricky with some of the more advanced stuff, but I do have some actual real life examples in there, but I'm going to try and show you with conceptual examples as well to make it straightforward to understand the concepts rather than here's a very, very complex 1,000 filter pipeline or something like that, which is something I sort of did at Couchbase and it got quite complex to deal with. So I just wanted to try and give you a flavor of how you can do these very complex things, but explain it in hopefully a straightforward way. One of the things we wanted to focus on as well is like how you can send data to multiple outputs independently. How you can easily do that. There's quite a few vendors provide integrated stacks with agents that just send to their one output, but how can you use like the CNCF open source project like Fluent Bit to easily plug in new outputs, different outputs, stuff you want to send some data to different destinations and maybe you want to filter it, process it in different ways. And how you can do that without having data duplication. So just a quick overview of Fluent Bit. Hopefully, I wasn't sure how many people would know it, so I just wanted to give people a little bit of a background. So what is it? So it provides a collection of logs, metrics, and traces in a single agent with processing, filtering, those kind of data pipeline functionality, and allows you to send to multiple outputs. It's high performance, so it started life as an embedded solution. So that works quite well then for minimizing resource costs and stuff like that in some of the large cloud providers, which as you can see is then why they started adopting it as the default observability agent. So if you're running on one of the Cloud providers using Kubernetes, you will be using Fluent Bit somewhere in the stack, you just might not realize it. And also things like the observability agent for GCP, it can be installed on VMs as well. That's all based on Fluent Bit as well. So lots of people use it. It's not just a dumb pipe. So one of the things we're going to show in later webinars is how you can add processing and stuff before it leaves Fluent Bit. So it's quite useful in some places to add some context to your data. You know, like if I've got 1,000 clusters, which cluster is this coming from? So add some context there, but also things like redaction and stuff like that. You know, remove the data before you send it, rather than try and sanitize your database or wherever it ends up afterwards. So, and part of that as well is reducing costs. You know, if a lot of logs may not be very useful, so let's filter down the ones that are useful and send those to the higher cost receivers that can do a lot of analysis on it. And yeah, widely used, 8 billion downloads. I think that was July, I think. So it's probably June, July, I'm not sure when it's actually, so it's probably more by now. There's quite a few. So there's various outputs supported, lots of different vendors, OTel, and then generic TCP and HTTP. So a lot of the vendor plugins are based on top of the TCP and HTTP outputs, but there's generic ones as well. Internally, Fluent Bit just has a common data structure, and everything works on that and then just transforms it into the output. So it can work with multiplexing data coming in, multiplexing data coming out. And to touch on Michael's question, yeah, absolutely can work for vanilla Kubernetes. There's no reason why it can't. Yeah, a lot of the tests for Fluent Bit just run unkind in CI, but any kind of Kubernetes should work. It's just consumes kubelet logs, sends them out if that's what you're going to do with it. How does it work? So I've talked about inputs and outputs. Another term for them is sources and sinks. So basically, you've got various configuration options to control it. So we've got a declarative syntax in YAML or an older style format as well. And you connect these different sources and sinks together along with any transformation. So we call those filters in Fluent Bit terms. And you can multiplex input and you can multiplex output. So each of the filters or each of the inputs or each of the outputs can work with a number of data destinations. Data can be persisted to disk if you want. So if you need to ensure that you're not losing any data, you know, if there's some kind of issue with sending to your output, maybe it's gone down, maybe it's got some kind of loading issue, some networking problem like that, the data can be buffered and persisted to disk until it comes back up again and so on. There's a lot of different options in there. So touched on here like dynamic discovery. So the Kubernetes deployment, I'll show you an example a bit later on, deploys a daemon set typically. So that's the open source Helm chart by default. And that can get all the logs off the kubelet, can scrape metrics, can receive metrics and traces from the host and pass them on to wherever you want to send them. It can also query the Kubernetes API for extra metadata about the pod logs. So if you want to add the labels, the annotations, you know, names of the pod, those kind of things, that can all be done as part of your pipeline before it leaves your agent. And there's some powerful filtering as well available via Lua and WASM. So Lua, I don't know if anyone's used it, it's like a scripting language, but it gives you a lot of flexibility in your filters, what you can do. And it's very powerful, and there's lots of different integrations to it as well. So I just wanted to give you kind of an overview of what Fluent Bit is before we dive into some of the more detailed stuff. So today the focus is on routing. So how do we create our pipelines? How do we get stuff from input to output, maybe via some kind of processing, intermediate processing in the way. So I'm going to cover that now. So this sort of diagram was taken from the Fluent Bit docs. It kind of shows you how we can multiplex outputs, but how the different stages in the Fluent Bit pipeline work. So we start with input, we can parse stuff. So that's taking unstructured data like logs, which are just like maybe lines, and converting them into some kind of structured format. So internally, Fluent Bit uses a message pack format, which is a type of binary JSON, and it converts it into that, and then we can apply a set of filters. You don't have to, And then we can start routing it to different outputs. So this is the way you create these kind of data pipelines. And I've sort of shown you the old style non-YAML format here as well. So we've got an input for tail, an input for system D. We've then applied a filter, and then we've got multiple outputs here. And as you can see, we're matching either everything or only logs, depending on which output it is. So it's showing you how you can take data and grab the data for different types of different pipelines and send it to different destinations very easily. And in this case, it's slightly different with Fluent Bit. There's no duplication of that data. You don't have, sorry, it's slightly different to Fluent Bit. You don't have to copy data from one pipeline to another. There is just one pipeline. It just might have different outputs from it. So the data travels through the system. It's not duplicated. It's a single record that goes to the output. It goes to whichever outputs need it. When it's finished, it's released. So why might you want to do this? So typically in larger organizations or bigger deployments, you want to have logs and metrics from multiple sources. You want to get kubelet logs, you want to get system D logs to see what, is the kubelet failing, or is there some other stuff with the node? Maybe you've got some audit logs, some additional logs as well. Maybe it's not a case at all. Maybe there's a switch log, some stuff for a syslog or something like that. And you want to grab all those different logs and metrics and traces and send them to separate destinations depending on their type of data. Typically I've seen deployments where maybe when we're running stuff in dev, we get all the logs, but only for very 24 hours or something like that, so we can debug stuff and figure out what's going on. But then when we're running in production, you want to filter that down and say, oh, these clusters, only tell me about important things. But also stuff like if you've got any kind of security integration like a SIEM or something like that, you may want to push audit logs, stuff like that, to some kind of glacial storage, or some way you can do post-intrusion analysis as well to make sure, like, oh yeah, these are all the logs we got in production, but someone, maybe there's been intrusion and we can't trust those logs anymore. So let's push them somewhere else that we can make sure it's only, is never going to be attacked. So there's lots of different approaches for that. And we can do all this with a single deployment of Fluent Bit. So as I touched on before, yeah, you can send stuff to locally with the Grafana agent. You can send stuff to Elastic with the Elastic agent, but you can't send to each other that way. So it's quite useful to be able to say, look, later on, maybe we want to add another tool. We don't have to drop in, we don't have to figure out how to configure the existing data pipelines we have in the new tool. We don't have to redeploy this new tool and deal with any of the maintenance complexities of managing the life cycles of multiple agents. Do they interact with each other? Do they consume resources from each other? Those kind of things. And you can, if you just want to evaluate it as well, you don't want to deal with all that upfront cost. You just want to say, start sending data to this new wonderful tool I've got, or I want to evaluate on, and you can know for sure that it's sending the exact same data it's sending to the current one because it's using the same data pipeline as well. So that's just an example of why you might do this. There's probably other ones as well. So at a high level, how does routing work? So simply, inputs provide tags, and everything else, so the filters and outputs, match to those tags. So it's quite useful. So I've drawn sort of data pipelines here, but there's no direct way of saying this is, you don't say this is the data pipeline of A to B, A to A and B to B. What you're actually saying is each filter in that thing is matching to the data from A, that output's matching to the data from A, and this output's matching to the data from B. So that's at a high level how you provide routing. So that's a very simple example. I'll sort of try and dive into some of the specifics with how can you expand on this kind of independent matching where a filter can be part of multiple pipelines, an output can be part of multiple pipelines, and an input can be part of multiple pipelines, but without having to say copy data from pipeline A to pipeline B. No, you're just consuming the same data from the same input but in different pipelines. So, but to touch on that, I wanted to also give a bit of overview of what the data looks like inside Fluent Bit to kind of give you guys an idea of how this works. So I touched on it before. So internally, all data is transformed into message packs. So it's a type of JSON. It supports binary data and it's optimal, serialized, and those kind of benefits as well. The idea being You can have data from any type of source. It's in whatever format it's in, and the job of the input plugin is to transform data that it receives into the internal format. The job of the output plugin is the reverse. So it takes the internal format and converts it into whatever format the destination is, along with all the kind of handshaking and protocol stuff that needs to go along with that kind of output. And then filters, which sit in the pipeline, transform the data internally. They work on the internal format, so they consume it, do some transformation, and write the transformed data out. So that's how you can plug and play all these different things, because they work with the same data format. So you just put them in a sequence, and off they go, transforming the data, outputting it, and carrying on. So every record to do that has a timestamp. So typically you pass that from the log file, but it could just be a time that's received or something like that. It has the actual data that goes along with it. So the structured data you've got, like the actual log message, the actual metric, whatever it happens to be. And the important thing for routing is a tag. So a tag is like, I am the data for X or something like that. So you might have tags that says this is the audit logs data, stuff like that. And then anything that needs to work with the audit logs data matches to that tag. So it goes, give me data for audit log, and it will receive all the data for the audit log. Now something else can also say that, and it will receive the same data. And the tag generally stays the same through the pipeline, but there is a filter I'll touch on later, which lets you modify the tag to start migrating a pipeline, sending data from one pipeline into another pipeline and stuff like that. It gets a bit confusing. So here's an example I ran earlier today. If you convert epoch time, you'll probably see it's sometime this morning, UTC time. But I just wanted to show you an example using the container where I use the dummy input. So this is just an input that generates data for us without actually receiving anything, sending to a standard output. So that's an output plugin that just writes to standard output. Here we can see the tag. So in this case, I've not specified my tag. You can do, you can call it whatever you like. But in this case, it defaults to the name of the input plugin plus a numeric UID. So as this is the first input plugin, and we do 0 indexing because that's the right way to do everything, it starts with 0. And then we've got the timestamp. So Unix epoch time, so since 1970, and then the actual contents of the data you've sent. So the dummy plugin defaults to sending data that looks like this. So internally, it looks like it's just a JSON message. The standard output plugin just adds some stuff to highlight where the fields are, the key value pairs, those kind of things. So that's why it looks a bit like that. So I've tried to sort of show you the overall data structure there. And you can kind of see, so I've not specified it here, but standard output will match all tags by default. So it's saying, give me all the data for everything, and that includes dummy.0. So dummy.0 is the tag. So let's dive into tagging a little bit. How does it work exactly? So as I mentioned, all inputs need to provide tags. Now you can do that in various ways, and it depends a little bit on the input plugin. As to what exactly is supported, but these are the general approaches. So you can tag things explicitly. So you can say, oh, let's go back one. Say this is my log. This tag is going to be explicit. And you can actually use the same tag for multiple sources if you really want to start doing stuff as well. But it's just identifying the data for other things to match with it later. You can also say, here, use a wildcard. And that's quite useful for like the tail input plugin, which is the one that reads files on disk. It acts as if it's tail -f. And it will substitute the sort of name of the file it's tailing into the wildcard. So that's quite useful. I'll show you an example of the Kubernetes filter, but yeah, it's quite useful to say, like, just tail everything in this directory and tag it with a wildcard. But in this case, you can see I've also added a common prefix. So that's quite useful then to say, when I want to match, I can match log.star as well. And I get all the different things. I don't have to be explicit saying, give me audit log, give me this other log, give me this other log, give me this other log. No, you can just do wildcards. And then you can do regex stuff. So you can extract, this example was taken from the tail plugin, but you can extract the name of the log file if you want. Maybe remove the .log on the end because that doesn't make sense. I've used it in the past as well to do just to give a much nicer tag names than maybe the wildcard stuff would be. But it can be quite powerful as well. You can do a lot of regex in there, and you can use that quite powerfully. And then the last thing I want to touch on for tagging is there's a special filter called rewrite tag, which I'll show an example of later. But the thing with this filter is it can receive data with one tag and create data with a new tag. So it's quite useful for maybe sending data you received from one input off into a whole separate data pipeline. And you can allow it to the existing data to carry on in the current pipeline and mess about with it. So it gives you some very powerful options there if you want to set up some very complex data pipelines. Say you've got a common bit of processing, you apply to all your data or certain types of data. You can say, right, okay, when this data comes in, actually send it through this processing chain. The example I'll show later as well is about tagging it for specific outputs as well. So maybe all your logs go to locally, for example, in the cluster, but you want the audit log as well to very explicitly go to a scene, and then you can use rewrite tag to send it, give it a new tag that only the scene matches. I mean, you could do it in other ways as well, with the matching and stuff like that if you set it up appropriately, but sometimes it's quite useful, or you may have very disparate matching values you want to use, so it can be useful to completely rewrite it into a new format. Matching, so matching is like the inverse of tagging. So the idea being here, like if you have a filter and output, it sits there independently and says, I want to match data that's got this tag. It's not sat in a pipeline. You don't configure a pipeline in that way, saying do A, then B, then C, then D. What you're saying is this filter matches this data, and conceptually build a pipeline that way, but it's very flexible in the sense that you can send data to different pipelines quite easily. It just can be quite hard sometimes if you make it very complex to see those conceptual pipelines as well. You can, as with tagging, you can do it in the same way. So you can match by explicit matching, say only give me stuff that matches my log. You can say, as we said there, like match everything with the log prefix, and then maybe do regex matching if you're feeling very, like you want to hurt yourself with regexes. But I did touch, I have put a little warning there saying don't mix them, mix match and match regex in the same section. One does take precedence, but it can be a bit confusing if you've got a lot of config in between them. Someone will see the match and not see the match regex, or vice versa. So just make sure you pick which approach you're going to do. And my guidance as well always is like, if you can avoid using a regex, it's a lot easier to maintain for a lot more people. So try and keep things simple. So I wanted to kind of work through some of the examples of stuff you can do with hopefully some simple diagrams. I do have a couple of examples, but I didn't want to. It gets very tricky very quickly to show you examples in slides, so I just wanted to show you nice block diagrams of how that will work. So this is multiplex matching. So probably touch on some of the configuration aspects. So it doesn't matter what order you define inputs or outputs in. You can define all the outputs first and all the inputs right at the end, vice versa. Inputs always happen, at the beginning of the pipeline, they receive the data, and outputs always happen at the end, they send the data. Filters match in the order they're defined. So if you've got a configuration file, it will match in the order that they're defined in the file. If you're using the command line parameters, obviously then it will match in the order we define those in the command line. So that's just one thing to be aware of if you're doing filtering, is make sure your order is correct, and be careful if there's some powerful tools to include other files in your configuration file, and if you start using wildcards, sometimes the order is undefined, so it can be quite tricky. So just make sure you understand the order for filters as well. Now I wanted to kind of show you how this kind of multiplexing matches. So here there are actually two pipelines, but everything matches independently, as I sort of touched on before. So we have an input A with a tag A. This matches to the first filter because it says match to A. It then says, oh, there's another filter that matches everything. Okay, that also affects my tag A. And then we send it to output A because that matches A. but also we send it to this other output because that also matches A. B is slightly different. It doesn't go through the first filter because it doesn't match, but it goes through the second filter and then onto the all output. It doesn't go to the top output. So technically you've got A going to output A and the output all, and you've got B just going to output all. So I've tried to sort of summarize that. But as you can kind of see here, this filter is saying I match everything. So it's not part of a specific pipeline. It's just saying as I get data, give me data from here, give me data from here, because they both match, pass it along, and these then start matching. Oh, I only match tag A. Well, that's the same tag that's coming through here. I match everything. Okay, I'll grab everything. So that's kind of how it works. Hope that makes some sense, but we can discuss it a little bit in Q&A if you want as well. And now the rewrite tag filter. So rewrite tag is a special type of filter, which, you know, it can say, oh, look, maybe you've got some, well, this is very simplified, but generally you probably have some complex pipeline before each of these, and you kind of want to take a subset of the data and inject it into the other pipeline. And that's where the rewrite tag filter comes in. So it can say, okay, I match B, and then I'm actually going to create a tag called A. And what that means is it acts as if it's the input A. So it goes into the start of the pipeline and then carries on. So a lot of people maybe will define filters in order in their file. You know, so they have filter 1, filter 2, and then the rewrite filter. But actually, when it rewrites it, it starts at the beginning of all the filters because it's as if it is a new input. So it goes all the way back here and then carries on through here. And with the rewrite tag filter, you can say, so I've matched some data from B. I can either let it carry on or I can drop it once I've rewritten it. So that's quite useful as well. So you might be, oh, like I've got one pipeline going here, but actually want to take a subset of that data and feed it through this other pipeline here. So that's one way of doing it. So a real world example. A very common use case, and it's the default in the open source Helm chart, is you deploy a tail input and you deploy a system D input and you use the Kubernetes filter. So I've linked out to it there, but the Kubernetes filter is a way of querying the Kubernetes API for some additional pod metadata. So what we see here is we're like tailing all the container logs. So on a kubelet, so you deploy this as a daemon set. On a kubelet, it will have all the logs for all the containers it's running. And those logs have a consistent naming structure enforced by Kubernetes standard. So that naming includes things like the namespace, the pod name, and I think the container ID of the container name. The idea being, from those three things, you can then query the Kubernetes API saying, give me more details about this specific pod and this specific namespace and this specific container. And it can then add in all the extra stuff, all the extra metadata. So we start with lines in the log file here. We tag them with the Kubernetes prefix. So this will actually end up expanding into the full name of the log file. And then we're saying with this filter, match all the Kubernetes stuff, because I don't want to match system D stuff. That doesn't make any sense. It will just moan if you try and do that because it can't understand the tag. The system D stuff is all from the host. You know, it's all like the actual kubelet logs, general D stuff, all that kind of things that you might want to find out what's going on, not just with the container, but with your nodes as well. So what we're saying here is like, send me all the Kubernetes stuff, and I'll then go off and query the filter. But I wanted to show you this is very simple and very standard approach to deploying daemon sets. It should work on any Kubernetes deployment. You know, we just tail the logs, and then we add some additional metadata from Kubernetes, and then we can do whatever we like with it. Send it to an output, do some more filtering, whatever you want. So I've just got an example where I send it to standard out using the Helm chart. I ran this some kind earlier, so I'll show you in a minute. But I just wanted to touch on some of the tagging specifics here. So the kubelet logs, as I said, there's a standard. They must include namespace, pod, and container information. The tail input encodes this information into the tag. So we get, with that previous one, we get this tag here expands into var, logs, containers, and then like the name of the log file. So whatever it happens to be. And then we can use that stuff. We strip off all that stuff and take the namespace, the pod name, the container information, and say to the Kubernetes API, give me all the metadata. That's it. And this is quite useful to doing that. So here's an example, as I said, I ran this morning. So I ran this on Kind. You can kind of see it's using the kind of networking and stuff like that. So I used the open source Helm chart, linked it previously, and I just added a couple of, I overrode a couple of values. So I told it to exclude the Fluent Bit logs. Quite useful to do that, because otherwise you get into some weird, like, because I'm sending to standard output, it will keep reconsuming its own input and adding more stuff, so it just gets in a big loop. So I told it to exclude the Fluent Bit logs. And we can do that with simple annotations. So that's one of the benefits of the Kubernetes filter. You can tell it to ignore logs or use special parsers just by pod annotations rather than having to configure Fluent Bit. So here, I install it, and then I could go grab the logs for the actual Fluent Bit pod. And you can kind of see the output here. It's a bit, messy because it's just a simple example using standard output. You can see how this could be easily sent to Loki or Elastic or whatever if you want to do it. So we take the full log name, and you can kind of see in that we've got, sorry, I can't highlight anything. So we've got the name of the namespace, the name of the pod, I think this is the Docker container ID. It's all part of the standard. So this is the actual name of the file on disk, and then there's the directory as well. We've got the actual log message in there. You can kind of see it. So by default, tail will just take the whole line of data and construct a JSON key called log. You can add parsers if you want to sort of extract more detail from it, which is quite useful for like NGX logs, a lot of other logs. There's some JSON parsers and things like that if you've got JSON format logs, which is quite a lot are there now. And then, so that's the actual log message. And then you can kind of see the Kubernetes filter has added some extra Kubernetes information. So you can see the pod name here, and you can see the namespace it's in. You can kind of see its ID, all of its labels. I don't think this one had any annotations, but it's everything that Kubernetes API kind of gives us about the pod. So that's just a very simple example. Hopefully, with like an actual, this is what the code looks like. This is what it outputs. So, say you wanted to send logs to different outputs. I've got an example here using Loki and S3, could be anything. So here we're saying send all the container logs to Kubernetes and then send everything to S3. So it's just a simple way of doing it. And it can be quite useful in different situations. So as I say, this is a very simple pipeline. You probably start doing things like using a grep filter or dropping data, sending all the stuff to in-cluster destinations and then out of cluster destinations with some more filtering with action. Maybe add some context information, like this is the name of the cluster if I'm sending it somewhere remote. But then I just want to show it's fairly simple. You just have to deal with matching and tagging. That's kind of what I want to show you in this webinar. If you want to add a new output, so that's quite useful. So we've got an existing output defined like this. We're sending all our logs to Loki, including the Kubernetes logs and the systemd logs from the host. But say I come along and I say, oh, actually, I want to evaluate what's the performance of OpenSearch when I ingest these logs. Do I get any benefits, stuff like that. Now, you don't have to do anything other than add a new output. So all the existing pipeline stays the same. All the existing data is the same. It is the same. It's going through the same pipeline. There's no additional work to do to configure that. And you just say, send it to OpenSearch now. And you can extend that as you want to. You can also do targeted outputs. So I'm showing an example here of using the rewrite tag, but also I wanted to highlight, Fluent Bit's not just about logs. We do metrics, we do traces as well. So here we're using the node exporter input. So that's equivalent to running the node exporter option deployment on Kubernetes. And we're sending that to an endpoint that we can scrape. There's also a remote write endpoint as well if you want to send it direct to Prometheus. So here I'm matching the metrics, but here I'm matching logs. And also, actually, I want to pick a subset of those logs and send them to a scene. So I'm using those to be output here, it might be S3, it might be whatever. But what we're saying for the rewrite tag filter is you give it a rule saying, when you see data that looks like this, so maybe it has a specific field in it or a specific field with a specific value, whatever, you can say, right, take this data, create me a new tag, and then my my output will match that tag. So this data will carry on through the rest of the system to wherever it was going, but it will also create a whole new pipeline that sends just to the scene for whatever your rule is. So that was just trying to show you some of that. So there's some good examples of this out in the wild using Falco and a few others where you can have audit logs, security logs, those kind of things with Fluent Bit, and you want to send those to different destinations to maybe your normal Kubernetes logs or your container logs, which like developers want to see. Right, I'm touching on the final thing, processes, which are a feature. So it's a pretty generic name. I've linked out to the YAML config for it, but I wanted to touch on some of the performance aspects as well. So all inputs and outputs for a while now can provide dedicated threads for their processing. So when Fluent Bit started life, it was single-threaded, embedded, that kind of stuff. So everything ran on the main thread. But for a few releases now, you can provide dedicated threads for input and dedicated threads for output, which is quite good because sometimes retrying output, doing stuff with output can be, quite expensive. You don't want to block the rest of the pipeline, or maybe other outputs that are much quicker, handling their output fine. You don't want to slow them down while you're dealing with specifically slow output. So it's quite useful to use that. I'd certainly recommend it. The only issue is that filters run on the main thread, so you just have to be careful with filters. But to resolve that, what was being added recently in 2.1, I think, but Eduardo might be able to keep me honest on that, is that a new concept called processes. So these you can attach directly to inputs or outputs. And what that means is that any filter can be run for that input or output. And you can run a series of them just as you would a normal pipeline, but they're attached to the input or the output, and they use the threads and everything associated with it. So it's a good way to do some of maybe the more heavyweight processing for dedicated inputs or outputs. Regex parser can be quite expensive if you've written a hard regex, for example. So it's quite useful to do some of that. It's only available for the YAML config just because of the way you have to specify it and configure it. The legacy config doesn't really support it. I'm not going to go into too much detail on it, mostly because I haven't really used it in Angular too much, but also because the next webinar is going to cover a lot of the processing, not just using processes, but how to use some of the more advanced features, Lua stuff, and things like that. Here's an example that we use for benchmarking. I've linked it out just right into Grafana Cloud in this case. Actually, I sort of shrunk it a little bit to fit on the page, but for the benchmarking stuff, put together some VMs that run a Prometheus local Grafana stack on the VM, and also we send data to Grafana Cloud. So if you go look at the example, it actually said, it shows you how you can proxy data to two different sources and stuff like that. But I just want to show you an example of how you might actually do it in Angular. So here we're collecting all the node metrics and dealing with all the logs. We just collected the logs mostly to check for any issues, but also to exercise the loading on the disk as well. So we started having by generating lots of logs and seeing how it coped with whatever data rates, data sizes, those kind of things as well. So I've linked out to that. I think we're going to share the slides afterwards as well, so people should be able to have a look at it as well.